notes on Friday? Okay. On Friday, you guys learned about the sine wave and some features of the sine wave. So now we're going to talk about what the cosine graph looks like. Okay. So same idea. If you guys are looking at your unit circle, what I want you guys to think about is we want to pick some x values so that the y values are going to be some nice numbers to plot. Because if you're looking at the unit circle, like if you guys are looking at quadrant 1, are all those values going to be pretty? No, because we have some radicals in there, right? We have some fractions. And just trying to make our lives easier, do we want to graph decimals or fractions if we don't have to? Okay, so to start us off, let's start at when x is 0. Just using your knowledge, because you guys just quizzed on this yesterday, right? What is the cosine of 0? 1. Okay, what is the next nice x value I should pick if I don't want any decimals or fractions for my y? The x. Pi over 2. Because what is the cosine of pi over 2? You guys are going to make this so fun to grade these unit circles, the way you guys sound so unconfident right now. What is the cosine of pi over 2? 0. What comes next? Pi. What's the cosine of pi? -1. Good. I see a pattern. What am I jumping by every x value? Pi over 2 or 90 degrees, right? So what should the next value be? 3 pi over 2? And what do we get? 0. And then if I keep going, 2 pi, and we get 1. So if we graph this thing, I'm going to call this 1, label this as -1. And then I'm going to space out my x values so they look like they're about the same distance apart from each other. So if I'm following my table, the first value for x is 0, and we get 1. The next value for x is pi over 2, and we get 0. And then we get -1, 0, and then 1 again. So if I wasn't here to help you guys walk through this, if I were to connect those dots, guys, what type of function does that kind of look like? Absolute value, right? Or it kind of looks like, what else did you guys learn about in Math 3 and Math 2? Quadratic, right? Doesn't it kind of look like a U? Okay, but what we know about trig graphs, if you guys think about the sine wave, does it just do one cycle and then stop? Same thing for cosine. This gives us one glimpse. This is called one period or one cycle of the graph, but it's going to repeat forever. Okay, so I'm going to connect the points like this. But I'm going to leave the arrows like that to demonstrate that it's going to repeat. So this right here is one cycle or one period. And for period for our class, guys, we're going to use the letter capital T. And it's 2 pi because it takes 2 pi distance along the x-axis before the graph begins to repeat itself. Okay, is everybody cool with that? Does that make sense? Does anybody have any questions? So the main difference I want you guys to pay attention to is the sine graph. If you guys look back at your notes from Friday, the sine graph starts at 0, 0. Okay? The cosine graph starts at 1. That is how you guys can demonstrate and understand the difference between a sine graph and a cosine graph. Sine starts at 0, 0. A cosine graph begins at 1. Okay? So you guys have this box. So let's go ahead and fill out some important information. All right, so if you guys are looking at the cosine wave, I'm going to highlight this portion right here because this represents one period or one cycle. So if you guys are looking at this graph, can you guys predict for me what is the domain? All real numbers, because it's going to go forever this way and forever this way. Good. So the domain is going to be all real numbers, negative infinity to infinity. What is the range? Negative 1 to 1. The cosine wave, this was in our 2.3 notes. The cosine graph is even. Cosine function is even. How long is one period? 2 pi. Good. Now the x-intercepts, what I want you guys to notice is they all have something in common. Negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2. What do all those numbers have in common? There's a pi over 2. But if you're looking at the numbers also more closely, do you guys agree this is like negative 1 pi over 2? And then 1 pi over 2, 3 pi over 2, 5 pi over 2. What do all those numbers have in common? What? Yes, but what type of numbers are 1, 3, 5, 7, 9? They're odd. Okay? So the x-intercepts are going to be odd values of pi over 2. And then the y-intercept is important because this is how you identify what type of graph it is. The y-intercept is going to be 0, 1. Okay. Is everybody cool with this? All right, so let's move forward. Two sides. All right, so see if you guys remember anything from Friday. What number is the amplitude? The number in the very front. Whatever number is in the very front is the amplitude, okay? We have to take the absolute value of this number. So the amplitude in this problem, oh, you can use a calculator. The amplitude in this function is the absolute value of A, which is 2. Now, the period is going to not be 2 pi here because we have a multiplier in front of our x. Okay, so the period normally is 2 pi, right? So the formula to find the period is capital T is equal to 2 pi divided by, do you guys remember what the Greek letter was that we used for this number? Omega, good. So it's going to be 2 pi divided by 3. Now to find our scale, because the period changed, we need to take this number and divide it by 4. Because if we divide it by 4, then we'll have equal width between each of our x values on our graph. So we're going to take our period and divide it by 4. So 2 pi over 3 divided by 4. So if I take this value right here and divide it by 4, it's going to be the same thing as 2 pi over 3 times 1/4. The 2's cancel. So our x scale is going to be pi over 6.